Let's go for PHP and threads. It's about Zend Thread Safety. I'm going to see that in a minute. So, hello everybody. If you don't know me yet, my name is Julien Pauli. I'm French. I live in Paris. And I work for Synthio Labs, creator of the Symfony framework and the Blackfire tool. I've been a release manager of PHP 5.5 and 5.6. So today I usually don't program using the PHP language anymore, but I program the PHP language itself. So it's just a movement. You can find many stuff like that, and you'll be given the slides at the end of this conference. I'm going to upload them on the web so that you can review them later. So what is this talk about? It's about how PHP can be run in a threaded environment without messing with memory. So we are going to recall on how a computer can treat several tasks at the same time. So what are threads, what are processes and things like that. Then we are going to talk about the PHP multitasking model, just a recall. You should know about it, but just a recall. And then what is what we call ZTS, Zend Thread Safe mode. Perhaps you already saw such letters ZTS, so we're going to see that. And then we conclude with parallel programming using the PHP language, which is just not a good idea, but we'll see that. Okay, so it's just a reminder. It's not a full course about how a computer works, but computer architecture. So nowadays we have lots of CPUs, okay, in our machines, in our servers, and several core CPUs. Okay, even the smallest device now have CPUs which are very strong, and multitasking is easy. It's about concurrency or parallelism. So if you have concurrency, you get one CPU core and you divide the time and you give tasks to the same CPU core the following task. And if you want to run, so that's so fast that you have the impression that the computer does several tasks at the same time, but it's not the case. Okay, if you want to effectively do several jobs in the same time exactly, you have to use parallelism, which is using several CPUs on the same machine and treating several tasks at the same time. Okay, or usually today we mix both solutions. Okay, so this is about concurrency. Okay, so you have several tasks and they share the same CPU, the same CPU core. Okay, and this is about parallelism, where you have several tasks to run, but you have also several CPU chips to run the instructions together. Okay, so it's different, and you can mix that. Okay, so you can have several CPUs, several tasks, and share the CPUs as well, with several tasks crossing CPUs, which do bad things in NUMA and things like that. But anyway, okay, so that's how we design things. And a task to run has been defined so many years ago. We call that a process under Unix. Okay, it's the lowest level representation of a task, and I found these pictures in just Unix global architecture and things like that books. Okay, so you have many resources about that. And the OS scheduler does the job of distributing the several tasks to the several CPUs. Okay, or if you have one CPU, then it will be given to one CPU only. So what we can see is that processes are heavy. Okay, they are heavy, big guys. They need many structures to be allocated in memory so that the kernel can track what the process is doing. So you have many things like those you see. So UID, GID, effective ID, common current working directory, all the memory maps that will be given to the process, the priority, the signal masks, the values of the CPU registers at that time, so that when the process is taken out of the CPU and given back the CPU, it can restore the CPU state, okay? The kernel stack, so that's just the stack. And the file descriptors, this process opened, are memorized, are saved into this structure. So this structure usually is represented as a heavy structure, even if nowadays machines are very strong to run them. They are heavy guys, okay? So let's talk about threads, okay? So threads are lighter, okay, than processes. They only got, it's not all, okay, but they only got an ID, a priority, a mask, and they memorize also the CPU registers and several other things, but they've been designed like processes, okay? They are just lighter. When you design a thread, you have less information to save about one thread than about a process, okay? They are lighter in memory. So if they are lighter in memory, they are faster to be run on CPUs because the less memory you use and you touch and you grab from the memory, and the faster it will be, okay? Their goal is to be lighter and to be user-learned programmable, okay? Processes are as well, but it's a little bit harder to do, and it's easier to do with thread, okay? They are lighter, less structure involved, less memory access, movement, and management. This has been done with the sharing, okay? If threads are lighter, it's because they share a lot of things with the process they have been spawned in. So a thread, it's mandatory that a thread is attached to one process, okay? You cannot pop a thread without a process. You need a process, at least one process, and then this process can pop several threads into its own body, if I can image this like that, into its own memory image. Okay, so like you can see, in blue you have a process, and on the right you have a thread B, okay, which tend to be yellow, and on left you have thread A, which tend to be purple. Okay, so those threads have their own data, okay, but they share many things with the current process. So that's why they are lighter to use, they are lighter to pop, they are lighter to die, they are lighter to manage from the operating system point of view, okay? They share many things. They only got their own stack and their own registers and signal and priority as well, but okay? So as the threads live in the process, okay, if the process dies, all the threads die together with the process, okay? So if you crash your process, you crash every thread which have been popped from this process, okay? And threads share the process heap, data, signal mask, and file descriptors, and other things less important. But they got their own stack, their own signal mask, and their own CPU registers values, okay? So there is a danger here, because if several threads share the heap and the data segment while you're programming, you need extra care when you access that part of memory. Because if you only use process, you have your own memory. If you use threads, you share the memory with other tasks that could be running at the same time on another CPU than yours. So it's quite hard to program when you discover that for the first time, but after that, when you have experience, it's just a matter of doing things. You need extra care. You need usually what we call memory barriers, which are special CPU instructions that tell the CPU to lock memory in the hardware. This can be done nowadays. Or you can do that with software, a lot of software, with semaphores and locks and things like that, that anyway will use the hardware to perform the tasks. So if we compare, it's not a full course, okay, it's just the main IDs. Threads share the memory of the same process by default, and they share the file system context, which is pretty hard as well, because if you have one thread that opens one file, it's given a file descriptor, and this file descriptor is shared with other threads. So if one wants to read while one wants to write, etc., you have as well to lock the file system or find things like that, technologies like that. They share the signal handling as well, which is quite hard to manage as well. But like we can see, processes don't do this. So threads are a lighter process, and to be lighter, they have to share things with other threads in the same process. Okay. So how about PHP in all that? So PHP, you know how it works since 1995. It's always been programmed the same way. PHP does nothing, okay? PHP relies on the web server to process several requests at the same time, okay? So PHP does not want to, it's not really right, but PHP does not want to listen to hear about parallelism or things like that. You rely on fast CGI, okay, to treat several requests. So whether you use PHP as a module in the web server, nowadays we support Apache. We used to support many web servers in PHP 5, but we don't do that anymore because they are not used anymore. And in PHP 7, if you want to build a module for a server, well, you have to use Apache. So in this model, PHP is bound into Apache's process image and will depend on how Apache will treat the requests, whether it will use threads or whether it will use processes. PHP just doesn't know about this. Or you use CGI and PHP or fast CGI, which is handled by PHP FPM under Unix. Okay, it's the same. It's fast CGI for Unix, and this way you use processes. Okay, with CGI or fast CGI or with FPM. It's not the web server that takes care of this. This time it's PHP, that's exceptional. And PHP will fork itself and will wait for fast CGI requests to come and to treat them, okay? So PHP could live in a threaded environment, okay? Despite of itself. That means that if the administrator decided to run PHP, for example, under Windows, and you use Apache under Windows, then the only multitasking module which will be available will be a module which uses threads. Okay? If you use Linux or Unix more globally, usually you don't rely on threads to treat several requests, but on processes, because Unix has always used processes, okay? And under Windows, if you use Apache, you will use threads, right? Or you can always develop your own solution, because PHP is open source, and we have lots of source about that, what we call ACE API, Server Application Programming Interface. You can develop your own to connect PHP to your own system and to your own technology. And you could use threads as well to treat several requests. So that means that PHP can be used in processes to treat several requests or in threads. And usually you don't master that when you design PHP or when you use the PHP language. You can't know in advance if you're going to run in a thread or if you're going to run in a process. Chances are that you're going to run in a process because nowadays we heavily use Unix platforms. But some cases like Windows Apache or Windows and other servers could use threads. Okay, so you must be prepared to that. So that's why internally there is a layer of code, C code, okay, that has been developed to protect the PHP interpreter when it uses threads and to lock the memory and to affect memory to threads. So that's what we're going to foresee together. We call that ZTS. ZTS stands for Zend Thread Safety. So PHP, the PHP code, the PHP interpreter can be run in threads or in processes. You don't really know how it will be used. So you have to use a special layer when you develop extensions or when we develop PHP to protect our global variables so that when we access them in threads, they are protected automatically for us. When it's a process, we have nothing to do. It's very easy. You access your memory, whatever you do. You usually don't need logs or things like that. And when you have a Zend Thread Safe PHP, it's written in the PHP version, like you can see here. That's PHP 7, okay? And if you use a non-thread safe, that's NTS, which says this PHP interpreter is not protected against thread safety, so it can't run in threads, and that one can. Okay, so this is ZTS or NTS, non-thread safe. So ZTS is a way of programming PHP core and extensions in C. It's a layer that is access to global variables by protecting the memory. We're going to see how it's done. So it's not very hard to understand. You know that to implement threads, usually you need to use a library, because if you don't, you have to program that directly with the kernel, which is a little bit hard to do. And the syscall is clone, for those who knows it. And usually, so you use a library to support threads, and you have several libraries available. And usually, nowadays, the most commonly used one is called Pthread, which stands for POSIX thread. It's a library which respects the POSIX standard, okay? But you have several other libraries which are less used on average, but you still can use them. You can choose the library you want PHP to use when you compile PHP with the flag ---- with TSRM something, so TSRM PTH, TSRM Pthread, or etc., etc. Okay, if you don't specify it, there will be an automatic detection of your system, and usually Pthread will be used because Pthread is now mature. It's available under many Unixes flavor, Mac and Linux and many things. So usually it's what is used. But as those libraries are very different in how they work, the ZTS is a code that abstracts that for us. It's just an abstraction layer, so that when we program PHP, we say, I want to access this variable, just lock it for me, and it will use the right calls for the about the right underlying thread library to use for me. I don't have to care about this. So TSRM stands for Thread Safe Resource Manager, okay? That's what it means. And this is a C code layer. It's in the TSRM / folder in PHP source code. So if you grab PHP source code and you want to study how it does to handle several threads, you can still look at the code in TSRM directory. If you want to build PHP with TSRM, so if you want to run PHP in a threaded environment, you have to compile it with ZTS, with TSRM activated, and you use the switch enable-maintainer-zts. Okay, that will build a ZTS PHP. If you don't use it, the PHP will be non-thread safe. Don't use it under thread environment because everything is going to blow up at your face. Okay, so here is an example program. Yes, we can read. Was afraid about the green and the black, but it's okay. Here is a program which is an example of what could be a very, very tiny PHP extension or even PHP core source code. Like you can see on the top example, we use a true global variable in C, okay? And this is perfectly valid here because we are in the what we call the minit module initialization step hook of PHP. That means that no threads have popped yet. PHP just started and is about to run. So here you can access true C global variables with no problem. On the bottom example, it's different because we are in what we call init, which is initialization of the requests. So here, PHP is actually about to treat a request, so the interpreter could live in a thread at that step. So here, you are not allowed to access your true global variable like the static int val we have above. You can't access it like this because it's going to blow up at your face. So what you do usually is that you use a macro, okay, which has been designed for that, and that macro will resolve to something like this. If you don't use the Zend Thread Safe, as we can see, the macro will resolve to just a global symbol. Okay, so you are in processes. You don't have to have your own memory because you live in processes, so the kernel already took care of that stuff for you, so everything all right. If you live in a thread, like we can see, it's a little bit, well, it's more complex, okay? We have many code and many things like that, and we have a void star, so as soon as we read more than 2 stars, that smells like some complexity under there. Okay, so we're going to detail how all this stuff works. How does that work? So just take an example with Pthread, okay, but for 6 threads, but it's exactly the same for other libraries, right? So in Pthread, each thread is given a key, and that key is used to access the TLS. TLS stands for Thread Local Storage, okay? Thread Local Storage is the piece of memory owned by each thread, and the compiler takes care of that for you. So that's a wonderful technology which appeared after threads appeared. So that's a little bit sad, but now we can use them. This is where we'll store our globals. So it's easy. You declare your variable as being a TLS variable, and then when you compile your extension or PHP, the compiler will generate special instructions to assure this piece of memory will be owned by each thread that will be popped in the future. This is what we call TLS. You have many articles about TLS if you want to read more. So, for extensions compilation, at compilation, each extension will declare a pointer to some TLS space. You have a special macro, so this is a macro of mine, but it's not very far from the Zend macro. So you declare your globals in your extension. This is how it's done. Like we can see, this will declare a symbol which is a void star. So if it's it declares a symbol to some area of some size somewhere in memory. This is void star, okay? And this memory area is bound to the current, to the future to be current thread, because we are just about compiling our extension. We don't use it yet. And this special area we're going to see will retain the variables, the global variables of every one, of every extension, of the full PHP image for that thread. And into that, you will have to browse the memory and get your specific memory area for your extension. And you will use the ID for that, because we're going to see a void star is just an array, okay? And the ID will be used to browse the array to get our specific globals. So this is how it works. The storage is the TLS storage for each thread, okay? And into that storage, we use our ID to grab our own globals, and we don't have to we have to use our ID. If you don't use your ID, you can access the globals of another extension of PHP, okay? So basically, when a thread pops, PHP will allocate a memory area of the size of every global PHP will need, and it will shrink it as an array and give the ID of the specific zone for each extension to pop its own variables, standing next to variables of other extensions for that thread. We are talking about global variables per thread. That's all, okay? This is an extension Blackfire that developed for Syncio Labs. So I took this as a picture. So how does it work? This is done at every new request. Okay, if you use a debugger, this is a front end for GDB. Okay, we can see that clone is used, .s, so that clone is obviously coded in assembler. So clone is called. Then it starts a thread. Then you go into Apache, work thread, process socket, Apache run connection, Apache run handler, run PHP handler. Oh, go to TS resource X. So every time a new thread is popped, a special PHP function is called internally, which is called TS resource X, and if it does not find resources, it's going to call allocate new resource. This is what I told you before. This is just about reserving, allocating space for the globals for the current thread to be used. Okay, so you just allocate those. This is done. This has been summed up, even if it's a big example for the function. This is the allocate new resource function. Okay, so it allocates resources for the current thread. Okay, and as we can see, we cannot see the lock, but we can see the unlock. So if you see an unlock, you can smell that there has been a lock before. So this is done under lock. So what's nice in PHP is that when the thread is popped, okay, it should not occur many times, because PHP pops many threads and then you're done. When the thread is popped, PHP locks memory, it books some part for every globals, for every extension for PHP core, and then it locks memory, and when it's gonna run, it doesn't need to lock it anymore, because it has already allocated its own area. So PHP is well optimized when used under threads because it does not need to lock the memory every time it must access in read or in write the memory. It's been prepared before. That's why PHP is fast nowadays, okay? So extension thread startup is easy. For each new thread, extensions should read the local storage. So this is what we call global init, okay? Ginit function, global's initialization, okay? So we use a special macro which is called Zend TSRM cache update, okay? This is thread safe resource manager local storage cache update. And when you start your globals in your extension, you have to write this. If you don't do this, then you're gonna have problems with performance. So this resolved to a TSRM get ls cache, which gets Pthread get specific. That's wonderful. That says, give me the specific storage for that custom thread actual, and put it in that variable TSRM ls cache. And then you use your macro to access your specific globals into your extension or into PHP core or into the Zend virtual machine or into everything that could live in a thread. That means the whole PHP interpreter. Okay, so you use it like this. You use back your TSRM ls cache, which is the cache for all the area, and then with your special ID you access only your globals which have been booked for you by the engine. Okay, so this can seem a little bit complex if you're not used to C programming or parallel programming, but that's a nice layer, okay? Because it is and it abstracts everything for PHP developers. If you for extension developers, so if you want to use to develop your own extension, okay, I'm writing a book actually which is called phpinternalsbook.com. So I'm trying with other PHP contributors to document the source code, even if for me the best documentation of an open source is the code. Okay, it shouldn't need any documentation, but actually I'm documenting it. So if you want to have a go in PHP extension development, using threads is very easy because you will use the ZTS layer. Okay, you compile with enable static TSRM cache. You don't have to take care about this. Usually this is done for you. Okay. And then you will have your ZTS layer activated. So it slows down PHP startup, but we don't care about that. Okay, if PHP starts in 100 milliseconds instead of 90 milliseconds, we don't care about starting PHP. Okay, it can be long. Yes. Okay, do your job, prepare. Because now you're going to treat thousands of requests and I want you to treat them fast. So the initialization of PHP is a bit long for that. Okay? It slows down also request creation for every new thread. Okay? This is clearly acceptable. This is just a matter of several, 1 dozen, 2 dozens malloc per thread creation. Okay, that could be way, way worse. Okay, so it's perfectly valid. So when do you need to use Zend Thread Safety? If you run Windows with Apache, you have to. Nowadays, it's nearly the only usable use case. Okay, yesterday under Windows, yesterday means yesterday. Okay. 2000, 2005, or before 2000 year 2000. There used to be many other technologies with Apache, like internet server from Microsoft or things like that, that used special modules of PHP, but we don't support them anymore in PHP 7, so Nowadays, if you run PHP under Windows, you have two choices, whether you use Apache, and if you use Apache under Windows, you will have to have a ZTS PHP, or under Windows, you still can use fast CGI, which will just use processes. And in this way, you won't need ZTS, okay? Or if you run Unix, you could need ZTS. Like if you want to play, I'm going to have a word about it in a minute, with the Pthread extension of PHP, okay? There is an extension of PHP that allows you to play with threads in PHP userland. I don't recommend to do it, but you can do it. This extension is called Pthread, okay? And if you want to use it, obviously you will have to compile PHP with ZTS. That can't be, okay, another way. In a huge majority of cases, anyway, you use Unix and you won't need ZTS, okay? It's a huge majority. If you want to check if ZTS is used in PHP userland, in a PHP program, you can use probe for the PHP ZTS constant, which says 1 or 0, something like that, if PHP is ZTS or not. If you need to detect that in a PHP script, what could be the use case? I have no idea at the moment. Okay, you see PHP -v, PHP version, okay, it tells you, or the PHP information, okay, the purple blocks tell you somewhere with the TS and thread safety enabled or yes or something like that. As a PHP developer, you shouldn't care about ZTS in your code, okay, because the PHP core developers made everything so that the PHP userland can use things and don't care about how memory is allocated. Is it in a thread or not in a thread? This is easy to do, okay? In other technologies like Java, for example, sometimes you have, if you play with threads internally, you have to lock your memory zones or things like that. In PHP, you don't have to talk about it or to think about it, okay? The ABI is broken between ZTS and non-ZTS, so that's why when you compile an extension, it goes in a folder which says if that extension is or is not Zend Thread Safe. Okay, so you build an extension, you're given a .so file, a shared object, and you can't get that extension and put it in a PHP with ZTS. That won't work, okay? It's not compatible from the binary interface. So you have to recompile it, rebuild your extension, once for ZTS, once for non-ZTS, okay? You have two extensions, and they usually are stored in a special directory which helps you remember if it's been compiled ZTS or not. You can use threads in PHP userland. This is possible. You need Pthread for that. Okay, it's on pthreads.org or on the manual of PHP. It's actually experimental. Okay, and it's just a toy. Okay, the developer which developed it, I looked at the code, etc. It's just about having fun with PHP internals. It has never been very serious, if I could say, even if the code is nice, but I wouldn't use that. I wouldn't use PHP to treat several tasks at the same time. It's not been designed for that. First thing. And second thing, I wouldn't use something which is a little bit experimental for critical business things. So you can toy with it, you can play with it. If you find bugs, just report them. It's on GitHub, okay? But I don't recommend to use it for production code or things like that. PHP with threads. Okay, not a really good idea. Well, you know, computers like me, okay, you know, PHP is not the only language in the world, and there is no language that can do everything nice just for you. One solo language you have to master. PHP is not good for parallel treatments. It's not been designed for that. Okay. Remember the first, second, third slides. How are requests, web requests, treated in parallel? It's not PHP problem. it's the web server's problem. So from the start, when Rasmus created PHP, it said, parallel? No, I don't need. The web server on top of that has already done the job. Me, I have to protect my variables if threads are used over there, or if processes are used. Okay, PHP CLI has never been given love because PHP is a web technology. Okay, so if you want to parallel programming, you will use Java. You can use Go also nowadays, which is nice for that. You use C. I personally use C or C++. I'm not very good in C++, but okay. So if you want to use parallel programming, use a true language for that. Don't try to use PHP. It will just be, well, you can toy, okay? You can. I do, but sometimes we have serious things to do. So don't use PHP. Don't crash. Don't. Yes, it's gonna crash. Yes, it's gonna segfault. Yes, yes, yes. It's not been designed for that. I can use my bike to reach back Paris this afternoon. I can. I won't. Okay, you see the difference? If you want, you still can do it, but it's not been designed for that, so it won't work properly, okay, and it will not change. You still can, if you want, use PCNTL. You know about it, I think. It shadows Unix processes. Fork, wait PAD, signal, etc., etc., sigprocmask, etc. Okay. So you still can use PHP, or it's heavier than C for the same interface, but it's still valid, I think. Don't use it under Windows because it won't work, okay? Because Windows is a little bit strange and different from Unix, and PHP is a Unix technology, so it's not available under Windows, but you still can use it. So concluding, this is the last slide. PHP is thread safe, okay? So PHP is not thread safe on Stack Overflow or things like that. Don't trust the web, trust the guys who put their hand in the code. Okay? When you hear things about PHP, it's not thread safe, I heard that. You heard that. Let me tell you how it works, because I know how it does. So PHP is thread safe. If you need thread safety, you shouldn't need it on an average use case, but if you need it, you enable maintainer-zts, okay? When you compile it, that will activate Zend Thread Safety. Then every extension developer should have done its job the right way. Okay? PHP is hurt. PHP is engine. PHP's technology is thread safe. If you plug in an extension which is not thread safe, it's not PHP's fault. Okay? It's yours, it's the extension developers. It's very easy to make an extension non-thread safe. It's 4 lines of code. Okay, you just create a global and you access it in requests, and then you put that on the web server, and someone does something for the memory is going to blow up, and you're probably going to crash the server and everyone with it. So PHP is mature, PHP is thread safe. Take care of exotic extensions, but nowadays strong extensions, those you use every day, are thread safe as well. So it's not a problem. Good. Okay, thank you.